Welcome back to Mindcast. I'm Will, and this is part 2 of our 3-part series, The Measure of All Things. If you caught our first episode, you remember we dove deep into the landscape of AI training data, what I called the known world versus the uncharted territories. Today, we're going to get our hands dirty with something that might completely change how you think about AI reliability. We're talking about factual integrity in large language model training data. And I've got to tell you, what I discovered while researching this episode absolutely blew my mind. So here's where we're starting today. There's this persistent myth floating around, and I mean persistent, that our most trusted sources of knowledge are fundamentally broken. I keep hearing people say that Wikipedia is less than 20% correct, that Encyclopædia Britannica is similarly flawed, and therefore, well, if our best sources are that bad, imagine how terrible all the other stuff must be. It's become this fatalistic assumption that underlies a lot of conversations about AI training data quality. But here's the thing that's going to surprise you. This foundational premise is not just wrong, it's spectacularly, demonstrably false. And the real kicker? It actually inverts the entire problem we're trying to solve. The issue isn't that our best curated human knowledge is factually incorrect. The issue is that large language models aren't even being trained on this high-quality curated data in the first place. They're being trained on something completely different and vastly less reliable. Let me take you back to where this myth started, because it's a perfect case study in how academic research gets misinterpreted as it travels through the internet telephone game. In 2005, the journal Nature published a study called Internet Encyclopedias Go Head-to-Head. Now, this study did not, and I cannot emphasize this enough, did not find Britannica to be less than 20% correct. What actually happened was way more nuanced and, frankly, way more interesting. Nature conducted a blind study where expert reviewers compared 50 science articles from Wikipedia and Britannica. The results? Encyclopædia Britannica had an average of 2.9 errors per article. Wikipedia had an average of 3.9 errors per article. The study's conclusion was one of rough parity. Wikipedia comes close to Britannica in terms of the accuracy of its science entries. This was a testament to Wikipedia's surprisingly effective community curation model, not an indictment of encyclopedic knowledge in general. Now, Britannica wasn't happy about this. They published a 20-page rebuttal titled, and I love this, Fatally Flawed. They argue that Nature's methodology was deeply problematic. They said reviewers were sent articles from the wrong corpus, got partial articles instead of complete ones, and that Nature failed to fact-check their own expert reviewers. And here's the fascinating part. This 2005-2006 dispute over roughly 50 articles was deeply contested. The notion of doing the same analysis for the billions of pages in an AI training set, that's not just logistically impossible, it's a methodological fantasy. And Wikipedia has only gotten better since then. A 2019 study published through the National Institutes of Health found that Wikipedia's quality is now very high, and that the number of errors it contains is on par with professional sources, even in specialized topics such as biology or medicine. So, we're not dealing with fundamentally unreliable sources here. We're dealing with high-trust, high-factuality data that gets continuously improved by millions of editors worldwide. But here's the plot twist that changes everything. Large language models aren't trained on Wikipedia and Britannica. They're not trained on carefully curated, professionally edited sources. Instead, they're trained on what I call the curation cascade, a series of increasingly filtered versions of the raw, unaudited public web. And each step in this cascade introduces its own problems. While failing to solve the fundamental issue, we're starting with unreliable source material. Let me walk you through this cascade, because understanding it is crucial to grasping why AI factuality is such a mess. It starts with Common Crawl, a massive 9.5 plus petabyte archive of the raw web, containing data from over 300 billion pages. This is the bedrock of most foundational models, including GPT-3, Llama, and T5. And its factual integrity is compromised from the very beginning by what I call its original sin. Common Crawl respects the robots.txt protocol. This means websites can opt out of being crawled. Sounds reasonable, right? Except this systematically excludes high-trust, professionally edited sources like the New York Times and countless subscription-based academic journals, while systematically including the chaotic amalgam of spam, boilerplate HTML, and offensive content that permits crawling. We're creating a factual quality gap right from the start. Common Crawl is a skewed representation of the internet that over-indexes on low-trust content by design. And then the data processing itself introduces new factual errors. The 2024 review found that the non-English portions of Common Crawl are heavily polluted by low-quality machine translation. We're talking about incorrect translation of dates, names, location names, and most critically, changes in numerical values. Stock exchange information, exchange rates, percentages, prices. A factually correct German stock report gets passed through this pipeline and becomes a factually incorrect piece of English training data with the wrong numbers. So Google recognized that raw Common Crawl was unusable and created the colossal clean crawled corpus, C4, to train their T5 model. This was an attempt to automatically filter Common Crawl using heuristic-based rules, removing short lines, discarding non-English text, and deleting any page containing a word from an open-source bad words list. This experiment in automated filtering was, and I'm not being dramatic here, a comprehensive failure. The filters created representational bias by disproportionately removing text related to minority individuals, including non-offensive content about LGBT+ people and text written in African American English. Meanwhile, they failed spectacularly at their primary job. A 2023 Washington Post analysis found that C4 is contaminated with content tied to white supremacy, propaganda, and conspiracy theories. The same analysis discovered that Book.org, a notorious market for pirated ebooks that has since been seized by the U.S. Justice Department, was one of the largest data sources in C4. This led to a philosophical shift. The nonprofit Eleuther AI created the pile, moving from automated filtering to deliberate human-led curation. The pile is an 825-gigabyte dataset composed of 22 intentionally selected, high-quality sources. Archive research preprints, PubMed Central biomedical articles, USPTO patent backgrounds, free law legal documents, and a large scrape from GitHub. By design, these components are of much higher factual quality than a web crawl. The problem? The cornerstone Books 3 component was compiled from a pirate ebook website, including over 170,000 copyrighted books that triggered major losses. This reveals a fundamental trilemma in dataset creation. You can pick, at most, two of the following: massive scale, high factual quality, or ethical and legal sourcing. C4 aimed for scale, sacrificed quality, and failed on sourcing. The pile aimed for quality, sacrificed scale, and also failed on sourcing. No foundational dataset currently in use is clean in all respects. Now, instead of trying to calculate some impossible overall correctness percentage, let me give you something more useful: a typology of the factual errors that we know contaminate these datasets. These aren't random mistakes, they're systematic problems that fall into 4 primary categories. And understanding these categories will change how you think about AI reliability forever. Category 1: explicit misinformation and disinformation. This is the fake news, propaganda, and conspiracy theory content that automated filters fail to catch. The models aren't just ignorant of facts, they're explicitly trained on anti-facts. Their training objective is to reproduce the data distribution, which forces them to learn to reproduce propaganda and conspiracy theories with the same confidence as academic facts. Category 2: data degradation and noise-based errors. These are factual errors created by the data processing pipeline itself. The data wasn't wrong at its source, but became wrong through automated processing, especially that low-quality machine translation I mentioned earlier. We're taking correct information and systematically corrupting it before it even reaches the model.
Category 3 is the most subtle and perhaps most troubling: popular misconceptions and systemic falsehoods. Large language models are trained to predict the next token, not to be truthful. If a popular misconception like humans only use 10% of their brains is more common on the web than the academic correction, the model learns the misconception as the more probable, and therefore more correct answer. This leads to a counterintuitive result. A 2021 study found that the largest models were generally the least truthful. We may have discovered a scaling law for untruthfulness.
And category 4, data contamination. This includes benchmark data contamination, where test questions used to evaluate models are present in the training data, creating artificially inflated accuracy scores. It's like giving students the answer key and then being impressed when they ace the test. This contamination hides the true impact of all the other error categories because we have no reliable measure of models' actual factuality. So, why can't we just calculate a single correctness percentage for all this data? Well, it turns out this question is not just difficult to answer, it's methodologically, logistically, and philosophically impossible. We're dealing with petabytes of data here. Manual review is financially and logistically impossible. But automated review falls into a devastating circularity problem.
Data contamination gets even more specific and problematic when we look at how it actually manifests. Researchers at Google discovered that popular benchmarks like HelloSwag, which tests AI reasoning ability, had questions that appeared verbatim in training datasets. But it's not just test questions, it's the methodology itself. When a model encounters "what comes next?" the chef carefully diced the onions then, during training, and later sees this exact same prompt during evaluation, it's not demonstrating reasoning, it's demonstrating memorization. This creates what researchers call evaluation theater, the illusion of capability measurement when we're actually just measuring how well models can recall training data. Let me give you some concrete examples of these error categories, because understanding how they manifest in practice is crucial. Starting with explicit misinformation, researchers found that Common Crawl contains substantial content from sites like InfoWars, Breitbart, and RT, Russia Today. These aren't obscure fringe sites. They're major sources of deliberately constructed false narratives. When GPT models encounter claims like climate change is a hoax perpetrated by global elites, they don't have any inherent mechanism to distinguish this from legitimate climate science. They simply learn that both types of content exist in the training distribution. Current automated fact-checking methods rely on stronger LLMs like GPT-4 to verify claims from weaker LLMs. But here's the problem. GPT-4 was also trained on the exact same or similar unaudited, contaminated, error-filled data. We're using the unaudited web to check the unaudited web. It's a house of cards with no ground-level, human-verified foundation. This system can detect inconsistencies between models, but it cannot establish ground truth. Data degradation errors are equally insidious but harder to spot. A 2023 analysis by researchers at Stanford found that when German financial news gets machine translated into English for Common Crawl, numerical errors are rampant. A stock price of euro 127.45 becomes $127.45. Same digits, wrong currency, and wrong value. Exchange rates get scrambled, percentage changes get inverted, and dates shift between European and American formats. The original German reporting was factually correct, but by the time it reaches an English language AI model, it's teaching the model that BMW stock trades at the wrong price in the wrong currency.
And before we even get to the data problem, we need a ground truth database to check against. For the entire internet, no such database exists. This brings us back to that Nature versus Britannica dispute. Who is the arbiter? What counts as a fact versus an omission? How do we handle subjective disagreements? Even reputable news platforms can contain flawed data claims. The ground truth problem is intractable at scale. The popular misconception problem is perhaps the most philosophically troubling. Consider the 10% of your brain myth. Neuroscience has thoroughly debunked this. We know from brain imaging that we use virtually all of our brain, just not all at once for the same task. But here's what happens in the training data.
The myth appears in thousands of self-help articles, motivational blog posts, movie descriptions, and casual social media discussions. The scientific correction appears in a handful of academic papers and educational websites. By sheer volume, the falsehood overwhelms the truth. The model learns that when humans discuss brain usage, they're statistically more likely to reference the 10% figure than the actual neuroscience. Token prediction doesn't care about truth, it cares about frequency.
So here's my direct answer to the central question. We do not know the percentage of factual correctness in AI training data. We cannot know this percentage, and any entity claiming to know this percentage is overlooking deep, circular methodological flaws in automated auditing. The only robust claim we can make is that the data is significantly and systematically contaminated with a known set of error types.
But this isn't cause for despair. It's cause for a fundamental shift in strategy. The field is already abandoning the failed experiment of trying to clean the entire public web. The move from C4's automated filtering to the pile's deliberate curation shows us the future. The path to more factual AI isn't a bigger model trained on all the web. That might actually make things worse. The future lies in domain-specific.
Think about it. An AI trained only on the high-quality components of the pile, PubMed, Archive, Free Law, would be vastly more factual in its domains than a general-purpose model, even if it couldn't write poetry or plan your vacation. We're moving toward the high-trust but inaccessible uncharted territories I mentioned in our first episode: paywalled academic journals, subscription-based news archives, digitized historical and cultural archives, and proprietary corporate and government datasets. The most critical realization here is that acknowledging the inherent and structural incompleteness of any dataset is the first and most crucial step toward building trustworthy AI. This fosters the necessary humility to move us away from the pursuit of an omniscient, truthful AI and toward the development of AI as a powerful but imperfect tool. The path to trustworthy AI isn't through a mythical, clean web crawl. It's through transparency of data provenance and deliberate, ethical curation of high-trust, domain-specific knowledge. So that's where we stand today. We've shattered the myth that our best knowledge sources are fundamentally broken, revealed the systematic contamination of AI training data through 4 distinct error categories, and explained why the auditing impasse makes global correctness metrics impossible. In our final episode of this series, we're going to explore the solutions, the emerging strategies for building more trustworthy AI systems, and the fascinating world of high-quality data that exists beyond the public web. This shift toward curation over scale isn't just theoretical. We're already seeing it in practice. Companies like Anthropic and Google are investing heavily in constitutional AI and specialized fine-tuning techniques that work with smaller, higher-quality datasets rather than simply scaling up on web crawl data. Until then, I'm Will. This has been Mindcast. And remember, the future of artificial intelligence isn't about having access to all the world's information. It's about having access to the right information, properly curated, and presented with the transparency and humility that complex systems deserve. Thanks for listening, and I'll see you next time for the final installment of The Measure of All Things.